Hello, we are Andrei, Victor and Andrei, and together we have developed a project for the 13th edition of the Digilent Design Contest. What we model is a smart trash bin, which can automatically detect different types of trash, such as metal, plastic, glass and waste. Through this, we want to make recycling easier for everyone and more practical. The system designed by us is a prototype, so it's not perfect. The objects introduced in the bin have to meet some constraints. Firstly, the objects cannot weigh more than half a kilogram. Secondly, all the objects must have approximately the same size and volume, and the objects made of plastic and glass need to be transparent and empty.
The objects introduced in the trash bin will be analyzed in a processing room. The processing room has three types of sensors: two infrared sensors for detecting the transparency of the introduced object, a 1 kg load cell weight sensor, and a DIY metal detector. From the processing room, after the object is scanned, the system will automatically open the corresponding compartment's door and the trash will fall in the right compartment. After the user introduces the object, they need to press a button which signals the system to start analyzing the object.
So, how does the system do this? First of all, it checks if the introduced object is a metal or not. If it's a metal, the analyzing process will end. Otherwise, the system will check if the object is transparent or not. If it's transparent, our design tests if the item is heavier than a predefined threshold, in our case 100 grams. This makes the difference between plastic and glass objects being heavier than plastic ones. If neither of these criteria is met, then the item does not fulfill one or more of our introduced constraints and will be regarded as waste.
As the brain of our project, we have used the Sabau board provided by Digilent Inc., which integrates the FPGA programming logic and the ARM processing system. The LCD shield mounted on the Arduino is used for displaying useful messages to the users. For detecting metal, we have used the following schematic from DZL's Evil Genius Lair blog. The link to his blogspot is in the video description. We've made the coil from the schematic using a copper wire. For detecting the transparency of an object, we have used two phototransistors and two infrared LEDs. The weight sensor is located under the trapdoor and is fixed in a Z formation. When an object is placed on the weighing end of the load cell, the strain gauges will measure the bending distortion. This distortion is processed by the HX711 integrated circuit, and then it sends digital signals to the Sabau board indicating the weight of the item. In order to make the Sabau board communicate with sensors that work on 5-volt logic level, we have used bidirectional logic level shifters, which convert 3.3-volt signals from the FPGA to 5-volt signals that go to the sensors and vice versa. Also, we have used 5 servo motors, which control the doors of each trash bin and the trapdoor from the processing room. After the object is analyzed, the trapdoor and the corresponding compartment door open simultaneously, making the object fall in the right bin. The compartment doors form a bottom-up pyramid, which enables the system to efficiently direct the trash to its right place. Moreover, we use 4 ultrasonic proximity sensors for detecting when a bin is full of trash. When a bin is full, the system warns the user by displaying a message on the LCD mounted on the top of the design.
Now we will present a short demo of how our project works. We will simulate how a plastic bottle, a glass bottle, a metallic can and a paper item are directed to the corresponding compartments after they were analyzed in the processing room. So as an example, let's take the metal can, place it in the processing room. Now the LCD tells the user to press a button in order to initiate the analysis process. As you can see, it was placed in the right compartment.
The second object that we will introduce in the system is a plastic bottle. Because it's not a metal, it's transparent and it's less than 100 grams, the system will take it as a plastic object.
Next, the system will try to detect a glass bottle. As the plastic bottle, it is transparent, but in addition it weighs more than 100 grams, so it should be detected as a glass object.
And our final object that we will introduce in the system is a paper object. Because it's not a metal and is neither transparent, it will be regarded as a waste object. Now we will simulate that the system tells us when a bin is full by placing a hand in front of the ultrasonic sensor from the waste compartment. It tells the waste bin is full. And now we can easily empty the compartments. As you can see, in the waste compartment the paper object was there. In the glass compartment the glass bottle was at its place. In the plastic compartment the plastic bottle. And finally the metal can was in the metal compartment.
Thank you for your attention.